This is problem 102 of Neetcode 150, house rubber 2. So this problem will basically use the solution of house rubber 1. So I strongly recommend you to go see the video house rubber 1 before solving house rubber 2. So once again, the concept is the same as the first of the series. We're going to have an array of integer nums, and at each position, we have a certain amount of money that this house holds. And we basically want to steal as much money as possible. But we can't steal two adjacent houses because otherwise there's a security system that will be triggered and we will be caught. Okay? Um, the only twist in this problem is that the first house and the last one, so index 0 and index n minus 1, where n is the length of the array, they are connected. So we basically a circle of houses. So let's just go back to this problem and actually pick up this code here, and I will explain it why. So um, I will have basically my function money. Let's just call this money, right? And I want to basically pass a number in it, but we will see why. Okay, so I will still explain a little bit this code. So to do so, I will just go back to our example, the same that we had in the previous video. So if you remember, um, we basically had two pointers. We have the R1, which means rub1, and we have R2, that means rub2. And every time that we move forward, what we want to do is that we want to keep track of a temporary variable. Let's call this t, and this temporary variable is going to be equal to the rub1 plus the next rub that we can do. The next rub is going to be this one here, so the one to the right of R2. So in this case, rub1, which is 100, plus the next rub, which is 300, is going to be equal to 400. So we have a temporary variable that will hold 400. And then what we want to do is that we basically want to move the two pointers, so R1 and R2. So we move them by one to the right. And after this, we want to ensure that the R2 is going to keep track of the greatest value we've seen so far. And the greatest value is basically going to be direct comparisons between what used to be the R2, so 500, and the 400. So same principle applies for the next round. So let me just erase this 400 so we can see the other example. So the next example is basically going to be, it's going to hold a temporary variable of 500 plus 150, which is 650. And by moving the R2 forward, we're just going to we're going to basically assert the greatest value between that 650 and that current R2 values. So the greatest value is going to be 650. So we're just going to move that and keep that 650 value. And our R2, well, it's going to be moving like that. And same principle here. So our temporary variable, it's going to be basically equal to the current value of the R1, which is 500, plus the next rep, which is 400. Meaning that now our temporary variable, it's going to be equal to 900. And basically the R2, it's going to be equal to the greatest value between that temporary variable and the current value it has. So it's going to be basically 900 that is bigger. So we're going to move our pointer by keeping that greatest value, which is 900. And then we can also move our right pointer. So by doing this, we can see that at the end, our right two or rub2 pointer, the R2, is going to keep track of the greatest value of money we can steal. So this was the house rubber 1. And the house rubber 2, it's pretty much the same thing, only this time the houses forms a circle. So the twist is that instead of simply saying, hey, let's just start rubbing all the houses and keep track of the greatest value we've seen so far, what I will do is that I will start by rubbing all the houses by excluding the last house. And then I will do pretty much the same thing. So I will still all the houses, but I will exclude the first house. So by doing that, we're gonna ensure that we don't have the first and the last houses that are duplicates of each other's. And not duplicates, sorry, but they won't basically be adjacent. So if we just go through all the array, we might potentially add the first the index 0 and the last index, which actually are adjacent in the case where all the houses are um, in a circle. So this is what we want to avoid. So this is why we are just going to basically send to call. So that's why we're using the exact same code of the house variable one, because we're going to apply the same code basically twice, and we're just going to be willing to take the greatest value between the call where we take all the houses by excluding the last one, and the one where we are taking all the houses excluding the first one. So we can see that this is basically what we did. So we have basically and I need to also um, initiate my R1 and my R2. So both are going to be equal to 0, and then the temporary variable is basically going to be equal to the first rub plus the next rub. And then I'm going to set, basically, I will just move my pointer. So the R1 is going to move to the R2, and the R2 is going to be the temporary variable, which is holding the greatest amount of money we can steal so far on at that particular place. And then we return the R2, which is going to hold the greatest amount of money we can steal overall. So that's the concept we're going to use, and we're just going to call this twice. All right, so we're just going to basically return in the function. So I will have two calls, so self dot money, and inside the money, the number that we want to pass is basically nums. First, we want to just exclude the last number, so it's going to be like this. So exclude the last number, and the second call, it's going to be self dot money, where we are excluding the first uh, the first the first house. But notice that if we have uh, an a nums with only one house, well, we are creating two calls. One that is basically in ignoring the houses, because if there's a nums array with only one house, well, that house accounts for the first and the last variables. So I just want to take this into account and basically add the nums 0 inside the return statement. And we also want to return the max of these trees. And in Python, you can return the maximum of 3 values. So yeah, that's exactly how we are solving this. I think I did some mistakes here, but that should make it. So let's test this out, and it works. Awesome. All right, so I hope you learned from this video. This is basically using a space complexity of big O of 1, since we are not creating any storage. In terms of time complexity, well, we are basically we're going to go twice through the array. So it's going to have a time complexity of 2n, which is going to be roughly just big O of n. So that's pretty efficient. It's the most efficient solution we can find. And with that being said, I hope you enjoyed this video, and I hope to see you in the next one.